Hey, welcome back to Fat Mama Physics! In this video, we are going to talk about solving equations when there are variables on both sides of the equation. I did promise that at the very beginning of every lesson, I will start off with a board game. Oh yeah, and I forgot, some of you mentioned, are wondering what the breakfast that I eat, so I have a chance to show you. Not with this camera, but let's see if I can tilt it. Yeah, so that's my latte, and then I like to have it with natto. A bowl of natto here. 60-degree egg, which is lovely. It's so silky. It's so nice. So good. Here, see if we can get a close up. But yeah, mix it up with rice. So here's the rice. This rice is not gonna fall down. Maybe you can't see it. Anyways, it's just rice, whatever. Mixed with rice, the espresso and the natto, they both have this beanie flavor that overlays. There's some overlap between the flavors, so it enhances both flavors individually. There's their own distinct flavors, but the bean flavor really puts them well together. And as well as the milk from the espresso, as with the egginess in the natto that I put in, the 60-degree egg. It really blends all the flavors together. It's so good. Okay, sorry about that. Let's get back to business. All right, so let's get on with the rest of this lesson today. I did say I was going to introduce a board game. So this one that I have over here is called King of New York. It is kind of like King of Tokyo, but it's like it's a different map essentially. So if you can't see it, this is kind of what it looks like. What the box looks like. Here we go. The board is it's a map of New York, obviously, as what the title says, and essentially there is a spot in the middle called Manhattan. Probably some of you been in New York might know of it. So this part of the board. Okay, so you kind of can see how Manhattan's in the middle. So as a player, it's a 4-player game. As a player, you choose one of these monsters to be. Can be anything, and basically you're wreaking havoc on the city. This is the player tile. This is your life health disc, so you can rotate it for health and stars and points or whatever. So this is a cool guy. There's a dragon here. There's a guy that looks like he came from space. And there's the one that looks like King Kong or Donkey Kong or whatever you like to call it. Anyways, all these different kinds of monsters. You choose one, and then you start off on the map. The monster that is in the middle, he has a very special ability. He gets to, when he deals damage, he gets to do damage to every monster on the map. So that's why it's called the King of, King of New York. And then whenever it's your turn, you roll these interesting looking dice. Here, let me put the map away. Okay, so you have these dice. No one can see it. It's got a paw symbol. This is where you get to attack everybody. This one looks like a dragon that a monster that got fried, so that's kind of doing damage to yourself. There's stars, wrecking buildings, getting hearts, stars, getting energy and whatnot. So if you're a monster in the middle, you do damage. You deal damage to everybody. You distribute the damage to everybody. The downside is that you cannot heal when you're in the middle. You pretty much go out, and if you don't have a way of leaving the city in the middle, then people attack you. You just won't be able to heal, okay? But yes, you do deal a lot of damage, and the idea here is distributing the damage, and that's the idea that I want to introduce in this lesson when we are talking about algebra and when you're being fair to every single term. I'll get back to it in a second. So let me put this game away. So this big idea of distributing something across many places in our equation is a common theme. You've seen it before in distribution when we dealt with polynomials, when we had to distribute the coefficient inside the brackets. You're going to see a little bit of that today in this lesson. Well, actually in a follow-up video later, but it's the same lesson. And the same idea when you're doing inverse operations on the both sides of your equation, you have to do the damage, basically. You have to deal with every single term. That's going to come up again. I'm going to reinforce this idea again and again and again. Comes back to the point where here you see this guy, he's got a balance beam, both sides are equal, okay? You don't favor one side over the other one, you have to do the same thing equally to everywhere, okay? So I have this little diagram, this little pictorial diagram here, which is the general idea, and then I'll do more kind of algebraic examples so that you get more practice, of course. So you don't really get to draw these pictures all the time. So here I have an equation, 6x plus 2 equals 4x plus 10. I have here a diagram of kind of what that looks like. Imagine this scale, you have a scale here, and it's got a tray on both sides, and in fact, it's supposed to be weighed equally. And so what happens, you have 6 of these x's in blue boxes, and 4 on the other side. These little single units you see has these green circles. So whatever that is, it's just representations, of course. This little X box can be anything. But then here's the thing though, because there are 4 X boxes on the other side, and I have also 4 on this other side, what I can do is I can just get rid of them. Because if I get rid of 4 on this side and 4 on the other side, that doesn't change the weighting in my scale. So this is like me subtracting 4x on both sides of the equation. So if I have to draw this algebraically, it would kind of look like this. If I subtract 4x on both sides like this, then this 4x gets rid of this guy over here, and 6x minus 4x leaves us with 2x. I include everything else on my equation, so that's the 2 single units and the 10 single units. So if you take a look at the this diagram over here, you can kind of see there are 10 of these circles left, and 2 x's and 2 little green balls on this side. But hey, there are green balls on this side, green balls on the other side. Why not get rid of those as well? So if we take out 2 more of these guys, then we are left with 2x on the other side. 10 minus 2 leaves us with 8x. So here's 2x in representation form, and if you count up all these squares, that should give you 8. Now we want to do the last thing, which is divide the masses within each pan into 2 groups, because in the end, we want just 1x. What is this 1x equal to? So if I kind of split this in the middle like this, if I get rid of half of that, then I have only 1x. I also need to do the same to the other side. I need to cut everything in half. So if these green balls were on the other side, I need to cut it in half. Then let me just get rid of half of them. Looks like there's 4 here and 4 on the other side, and that's exactly 8 divided by 2. Bam, 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 bam. Okay, and if I do that, divided by 2, I get x is equal to 8 divided by 2 is 4. So x should be 4. So I could draw this on this side, whatever. 1, 2, 3, 4. So x is equal to 4. If you don't think that's a very good trick, or actually it's not a trick, a good way to verify, to make sure you have the right answer, is to put in this x into the original equation. So that's back into this one. 6x plus 2 equals 4x plus 10. So let me put 4x in here. So let's write this out again so you can see. If I put x is equal to 4 in here, 6x, 6 times 4 is 24. 24 plus 2 gives me 26. Let's see if it's equal to the other side. 4 times 4 is 16. 16 plus 10 is 26. That checks off. Therefore, x equals to 4 is a valid solution to your problem. Okay, so that's the idea of how it looks like on a diagram. But you don't have the luxury of drawing diagrams for every single question. So we do have to get used to doing this algebraically. But now, hopefully, you can see why and how it works. Now, let's do more of these examples algebraically, and I'll show you how that works. So here, the goal in any equation is to always isolate for your variable. In this case, it is c. You want c is equal to blah, 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 whatever is on the other side. Okay, so how do we deal with it if we have, say, c's on both sides of the equation? What we want to do is we want to put them together. How do we put them together? You only want c on one side of the equation, meaning you have to get rid of the c's on the other side of the equation. And which side you choose to get rid of the c, it's half of it's personal preference, half of it can be a little strategic, depending on whether or not you want negative signs. Personally, I don't like negative signs. So I'm going to do this. Even though this equation, these instructions are telling you to add the blah, 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 negative 2c to both sides, you know what? Take a look here. I don't like negative 3c. Negatives tend to, I tend to get tripped up. And it happens to a lot of you as well. Not so much, of course, with lots of practice, but in the beginning stages, I recommend that trying to deal with less amount of negatives is always better, because I know how many of you always forget your negative signs. So here I'm going to get rid of this negative 3c. We know that in order to get rid of negatives, we have to add the opposite, which is positive 3c. So I'm going to add 3c here, and screw these instructions, whatever, plus 3c over here. So if I add 3c here, that gets rid of the negative, and then I have to add 3c to the other side. I am now left with 7 is equal to 2c plus 3c minus 8, okay? And notice that when I add something, I could just add it to the end of my equation, because I'm just adding it to this whole thing that's inside my brackets. Remember thinking, whenever you're doing the operation, you're always thinking that you're bracketing both sides of your equation. So then here I have 7 is equal to all of this, and of course I can put these two together. 3c's plus 2c's plus 3c's gives me a total of 5c's minus 8. It's like I have a bad report card or something. Now the next step is to get rid of everything else that is beside the variable. And remember, when we talked about in the previous lesson, is whenever we're trying to isolate for the c's, our variable, we have to peel the onion. How do we peel the onion? We need to make sure we peel the outsides first before we deal with the inside. The outside here would be this constant 8. It's a term that is not part of your variable. It's an outside term. So we get rid of this first. To get rid of negative 8, I'm going to add 8 to both sides of the equation. That gets rid of this one, and which then I am left with 7 plus 8 on this side. And then on this side, I get 5c. 7 plus 8 is 15. And then this side, I get 5c. Now, this is when we're in the insides of the onion. Again, we're now going to peel the inside of the onion by getting rid of the coefficient right beside c. The 5 and the c are the same term, so that's why we're on the inside of the onion. And then after we divide 5c on both sides of the equation, I get c is equal to 15 divided by 5. That is 3. Okay? So there is the example 2. Okay, I'm going to scroll down. So I'm just going to do example 3 here. Of course, I'm going to give you a chance to also do some of those as well by yourself. So let me start. Okay, I will be doing B. Okay, so I will do B, and I will do D. Okay, so A and C, I think you can give it a try. But then, guess what? Here, I'm going to let you do A first, and then I'll quickly go over it, okay? The ones I'm asking you to do, I will fly through the solutions. The ones that I will do, I will go more in detail about each step, okay? So, next question is A. It is your turn to do it. Good time to pause the video. Okay, so hopefully you've given A try. Okay, so take a look at this one. You do have A's on both sides of the equation. I'm going to move, of course, get them together. Again, I hate these negatives, and by moving the negative 30A, I get to hopefully make this side of the equation more positive. I'll show you what that means. I'm going to plus 30A on here. I'm going to plus 30A on this side. It gets rid of this, and I have 30A minus 6A is equal to 30. 30A minus 6A, that is 24A, is equal to 30. So that doesn't look very nice, but let's divide both sides of our equation by 24. Okay, and then this is going to give me A is equal to 30 divided by 24, we can simplify this, of course. If we divide the top and bottom by 6, then 30 divided by 6 gives us 5. 24 divided by 6 gives us 4 on the bottom. And that is my answer. You do not have to convert this to a mixed fraction. And I'm just going to leave it like that. If you do, that's about what? 1 1/4. Okay, so that was 6. Not too bad, right? Okay, I'm going to do B. Reason why I do B? Because take a look at B. It's got some decimals in there. Okay, so again, it doesn't matter if it's decimals or whole numbers. I still, same idea, want to get the variables together. So I'm going to try to move this negative to the other side. I'm going to change a color so you don't get confused. So I'm going to move the negative 1.2c to the other side by adding it. Okay, and therefore I can get rid of that. I have now 5 left is equal to 2.8c plus 1.2c minus 8. Okay, I can combine these two together. 2.8 plus 1.2 is 4c. Oh, we love when numbers work out, don't we? Now we want to, remember, peel the onion, get rid of the outside terms. I'm going to do that by adding the 8 on both sides of the equation. I'm going to get 13 on this side is equal to 4c. I'm going to divide both sides by 4 to isolate for my c. This is the inside of my onion. I get c is equal to 13 over 4. Again, I don't need you to simplify the fraction. You can leave it in proper form and that is fine. Okay. If you did simplify it, that would be what? That would be 3 1/4. Okay, anyways. Okay, so now you've dealt with some decimals. Guess what? Try C yourself. Good time to pause the video. Okay, so let's get down to it. Okay, so this is interesting because notice there's no minus or none of these variables are negative when I want to combine them. So I'm going to subtract it on the side where it's a little less. So that when I subtract the 6w on this side, from the 8w, I don't make a negative number. I still have a positive number. So 8w minus 6w is going to give me 2w minus 12.8. And this is interesting because that's probably never happened to you before. When you subtracted everything from one side of the equation, it doesn't just turn blank. You have to put something there. What do you put? A big fat goose egg, a 0. Okay, it's right there. So now we have an equation we can work with. And again, we're going to peel the onion because we want 2w by itself. I'm going to add 12.8 on both sides of the equation. So then this goes away. I get 2w is equal to 12.8. And now the inside of our onion, divide both sides by 2. I get then w, that rhymes, is equal to 12 divided by 2 is 6. 8 divided by 2 is 4. W is equal to 6.4. I don't need you to convert that to a fraction. Leaving it as a decimal is fine. Okay. Now, I said I would do the last question. So, let's see. It looks a little funky because it's got a lot of negative signs, but whatever. They're just negative signs. Get over it. Okay. So, again, I want to always add to get rid of to make my negatives more positive, I always want to add the larger positive here. So to get rid of, so I'm going to move a negative 5.7x to the other side by adding it to this side and adding it to the other side. This goes away. Now I am left with 5.7. Oh, actually, you know what? Fine. If you want me to, I can put the negative 2.5 in front. But it really doesn't matter if you're adding or subtracting in terms of the order. Plus 5.7x minus 2. I could have just written 5.7 minus 2.5x instead. And this is equal to 6 on the other side. So I'm going to combine these two like terms here. And that's going to give me 2 and 3. Okay, I should be right. Okay, 3.2x minus 2 equals 6. Peeling the onion time. Adding 2 to both sides of the equation, I get 3.2x is equal to 6 plus 2 is 8. Next, I'm going to divide both sides of my equation by 3.2. This is the inside of our onion, so that goes away. And then I'm running out of space, but I get x is equal to, good time to put that in our calculator, 2.5. All right. So here we have it. This is part 1 of 4.3. There's going to be a total of 3 parts. This one, hopefully, you got the idea if you see two variables on both sides of the equation, you must combine them together. And you're wondering, how does that have anything to do with the board game you just showed us about distributing things amongst everything else? Distributing damage. Yes, that is very important, and it's going to be coming up in the next few videos, so stay tuned for part 2. Thank you for watching. Good luck. Fat Mama Physics, signing out.